So we have with us Bassil Mohammad. He's a senior cybersecurity strategy and risk management professional. He's going to be talking about cybersecurity risks in industrial control systems. Bassil has more than 20 years of hands-on and consulting experience in cybersecurity strategy, transformation, risk, and resilience. He has worked closely with clients, senior management, and leadership across multiple strategic accounts in the Middle East and North Africa to architect and provide high-quality solutions. Being in IT, OT, cybersecurity strategy, and risk leader, with deep understanding of the market and clients' needs, emerging technologies, and increasing compliance mandates, he has introduced value-add cybersecurity services and scalable assets across multiple industries. Bassil graduated with a BSc in computer engineering, followed by a master's degree with a GPA of 4.0 in information security. And he holds several certifications in the areas of IT and OT. He is also an active researcher with several publications in elite accredited journals on various cybersecurity subjects. So with that, I'm going to hand the stage over to you, Bassil. We look forward to hearing your thoughts on the subject. Over to you, Bassil.
Yes, thank you very much, and thank you for the brief introduction. Just before I start, please just let me know if you can see my screen, so everyone can see my my screen or not.
Sorry. Yes, Bassil, I can see your screen clearly.
Okay, great.
You can go ahead.
Great. Okay, so thank you again, everyone, for joining this session. And unfortunately, this is the last session, so I can understand. Maybe it could be that this is for you the end of the day, and but I try as much as I can to make it entertaining, to the point, and something that I hope that you will get the most value out of it. So I'll be talking about cybersecurity risks in industrial control systems. So this is a bit of the agenda for this session. So I start with a quick introduction to what ICS is and what is ICS security, why it's important, and what are the most challenges actually that we have today in ICS. Then I will be explaining the PIRA model, which is more or less the ICS architectural model, a de facto standard available in the market. Then we will come across some of the risks and the threat vectors and how we can basically use the best practices to go into the very next item, which is the protection and having the right countermeasures actually to protect these systems. And towards the end, I will be sharing some of the real life scenarios and the stories actually from the same. So what is ICS in the first place? So there are so many actually definitions for what ICS is, but the most common definitions available are the two provided by NIST and Gartner. And NIST honestly has been very active into developing standards and best practices when it comes to ICS. So as per NIST, ICS is defined as a combination of control components that are basically put together to act to achieve an industrial objective. And these control components could be electrical, mechanical, hydraulic, or any kind of control components that eventually are put together to achieve some industrial objective. And the industrial objective in this perspective could be something related to like manufacturing a product, related to transportation, or in the energy field. From the other side, Gartner's definition actually highlights the fact that this is a combination of hardware and software that detects or causes a change through a direct monitoring and or control of physical devices, processes, and events, which is to a certain extent elaborating more from the perspective that it really shows you that this is not only about control components. So it really brings hardware and software together to control something. So at the end of the day, this system is a real-life system that's basically doing real actual something, real actual thing, as opposed to, I would say, the typical standard applications or systems that we typically see, for example, in the banking industry, where most of the applications are transactional in nature. Here, the perspective is a bit different. It is basically a merge between two worlds, the physical world and the real actual control world. Okay, where you can imagine that you are controlling, for example, the certain manufacturing process. You are controlling physical devices like bumps, certain machines. All these kind of different machinery or components are being at some higher level, basically being controlled and monitored to achieve something. It's quite important actually here to highlight the fact that ICS systems are sometimes referred to as being OT, or operational technology, and cyber physical, which is, I think, among those listed, cyber physical is one of those that is maybe not from a marketing perspective is really available, but more from a research perspective. So you can find it in the literature review and this kind of context where it is referred to as cyber physical. OT is more or less what we are basically going to be alternatively using to refer to ICS. Collectively, these comprise what is referred to as critical infrastructure as well. So any critical infrastructure in a country, more or less, it will have an ICS system or component being part of it. So just to elaborate more, to bring the concept, make it more clear. So this is how, again, NEST basically tries to explain the core operation of an ICS system, where at the middle part you will see you'll have the controller, and this controller is getting some input from the sensors or the field devices that are associated with a certain process to measure certain values. And as long as maybe there are some kind of deviations or adjustments that are needed to the process, the controller will be sending commands to the actuator to fix or to put again the process into the right track. And from the other side, you can see that there is what is referred to here as the HMI, or the human machine interface, which is the window, if you would say, that an end user will be using to set points, define algorithms, configure the controller in the first place. So just to take this through an example, so imagine the heating system, for example, that you are having that we have in our home. So the heating system has some kind of controller that at the very beginning you set a certain value for the temperature for, right? So for example, if you are setting it to 60 degrees, so you expect the controller to maintain this temperature at 60 degrees. So whenever there are any kind of deviations, the sensors will be sending back some values showing that there is some deviations, and where the controller in this sense will be, through the actuators, activating the process to set this back again into the correct or desired value in this sense. So you can imagine if the system for a reason stopped working, like for example, if someone managed to change the configuration. So instead of the desired 60 degrees, someone managed to go through the system and set it to 200. So you can imagine that the system now doesn't really know that it needs to stop at 60, and it will continue heating up until maybe real actual physical damage could happen to the underlying components. In the very same way, actually, maybe an attacker at some point in time will be able to cause the human at the very end, actually looking at the controller, to lose what we refer to as loss of view, in the sense that he will not be in reality looking at the real actual value that the controller is basically telling. So maybe it is reporting 60, but in reality it is not. So these are the type of things that could go wrong into these kind of systems. I'm super actually simplifying it just for the purpose of clarifying the concept. So some of the key systems or the key terms that are usually reported or mentioned into this context is the BLCs, which are the controllers, more or less the most common controllers used into this stage. and the upper higher systems like the DCS and the SCADA systems, which are the systems that are compromising the higher levels of this hierarchy. These things will be clarified more as we go through the slides. So where do we find ICS systems? You can see from this slide that they are really into the very critical components of any country, like into the water treatment, in the factories, in nuclear plants, tank farms, chemical plants, the power grid, all these kinds of facilities, I would say, they have ICS systems or components. So you can imagine if these ICS systems are compromised, what could be the impact if these systems or these facilities is stopped to work or stopped to do what they are supposed to do. There could be a huge impact in terms of like explosions could go, safety could be compromised, casualties could be there. Lots of all these kind of things could happen, and impacts on countries could be disastrous. If, for example, you have like a chemical plant completely going inoperational, or it's going like it has explosions because of like someone or an attack had managed to compromise the ICS systems there. So why is ICS security a hot topic in this regard? So there are several drivers actually for this thing, and these are really depicted from the actual things that I see in the market when I interact with the clients. So the first thing is the compliance mandate, and these compliance and the laws and regulations coming from different governments in the region and all across different regions are basically calling for more controls to be imposed on ICS and to really give security the needed attention. And this is simply put because these governments, they realize the impact and the threat that's basically going around the security of these systems. And from the other side, it's like the business insights or some kind of like the business driver. And the perspective from this sense is that, you know, we already have lots of investments in IT security. So there should be more or less the same done for the ICS or the OT security. And this should be coming together in a way that makes, from the business perspective, the best utilization of its like investments. And this is where we are trying to manage in a way or another the fact that IT and OT are converging, in the sense that some of the systems that we used only to see in IT, they are gradually becoming to be seen into OT as well. OT infrastructure is utilizing and using Windows operating systems, TCP/IP, and all these like different protocols and underlying components that we used to see only in IT. And this is at the end of the day exposing us and increasing the exposure surface for the OT world. And this will lead us to the fact that cyber threats are increasing considerably in the ICS world. And this is becoming one of the, I would say, like something financed at the nation, at countries level. So nation-state kind of attacks, including these kind of things into the warfare, all these kind of things are basically making the security of ICS really a topic, something that each and every country needs to take care of. The very big question that usually is coming here is why we don't just use what we have in IT for OT. If we are now gradually starting to use like the assets that we used to use in IT in OT, so why do we like to give it more attention? In reality, actually, there are lots of differences between the two worlds, between IT and OT, in terms of the kind of assets that are there, the kind of protocols that are utilized, and the nature of the systems themselves. And this basically imposes the need for treating them differently. However, as a best practice, this is what I usually recommend, is that if there are similarities between the two, we just take use of them. But this doesn't really should be perceived as a barrier for not really customizing things that only best fit for the OT work. And in the next slide, we'll see some of those differences. So you can tell here, for example, when it comes to the field devices that are used. So in terms of the data capacity, it's evident that they have very limited data capacity compared to what we used to see in IT, where we are having more or less, we are used to the end user computing devices, as opposed to the field devices in the OT world, which are limited into data capacity. Sometimes they don't really have any space to just merely put the configuration there. One other very big aspect, actually, that differs between OT and IT when we look at the subject is basically the priorities. So you can see that in OT, the priority is given for safety, availability, and integrity first, as opposed to the typical CIA model that we see in IT. So safety is given a considerable portion in OT, and you can imagine that if really something goes wrong in an ICS system, really this what could be the result, that maybe people could be harmed, explosions could cause the death of people, all these kind of things. They are given the priority when it comes to OT compared to the typical standard IT. One of the very big differences actually between IT and OT is the real actual place where the critical operations are taking place. So in a typical IT system, like for example, the core banking system, the actual critical operations are happening in the center of the network, or the center of the system, which is the core banking system that you are completely hosting within your facilities. So you have more control into its security, its physical security, and the other aspects of security. But when it comes to OT, the story is a bit different, because most of the critical operations, they are happening in the end terminals of the network, and most of the time these are widely spread into very big geography, and sometimes you don't really have even the control over the physical security of these locations. And the number of assets could be really in thousands, especially if you're talking about the power grid in the States, for example. You can imagine how many components at the end of the day are connected to each other. It's a very massive and huge heterogeneous kind of network that has multiple components connected, and each one of these components is depending on the layer, which is basically allocated and has different specifications, different protocols, just to mention some. One of the key differences between IT and OT is basically as well, something that's worth mentioning here is the response rate. So I'm just here giving the example of the batching, for example. We do batching in IT in a much faster base compared to OT. Because again, we don't really want to risk stopping one of these processing systems actually due to an improper patch, for example, that is installed without really proper testing. So these things more or less impose the fact that we need to treat OT a little bit different when it comes to IT, or the very traditional way that we deal with IT. This slide here, it shows some of the challenges, security-related challenges that we have in ICS. Just to summarize them, so we have lack of basic security controls in certain areas. And these areas are not only strictly related to technical aspects. It is both technical and non-technical when it comes to people and processes. And just to depict some of these, for example, under the governance area, you can see that change management and batch management, they are not really straightforward when it comes to OT, as we do usually in IT. They would require intensive, basically, effort to make sure that they are not really jeopardizing the system or causing any impact on the operations. Typically, and I have seen this across multiple clients, I would say, across the region, basically, governance from the perspective of like the roles and responsibilities, who does what, who does it when, all these kind of things, to a certain extent, either they are not defined or they are not, or they are defined in a very gray way that make it really inoperational. So when really the real thing comes in, people are suffering actually to do the right thing. So change management, yes, we mentioned change management. From the technical perspective, one of the key challenges actually there, especially when it comes to the OT networks, is the identification of the assets and the devices. To really have a very strong process in place to make sure that we are, at the end of the day, inventorizing these things, and we're aware about these components and how they are connected. All these kind of things could be, especially when you have a very massive and huge network, gradually increasing actually. This will turn this into a real actual challenge, where you end up really not having visibility on the different components that you're having, which is really a very big security issue when it comes to the fact that it is at the end of the day connected to your network, and you need to make sure that it is at least having the minimum security standards and controls that would prevent it to be a backdoor to your network. Here as well, I'm mentioning some of the, again, challenges that are there, like lack of security awareness, which is, I think, this is not really specific to OT, so you can find it. It is general, very general for security, but it is still applicable for OT, especially when it comes to making sure, for example, that you don't diffuse all the efforts that the organization did into bringing the best technology actually to protect your network and your infrastructure, by simply ending up with like a user who doesn't really have the proper level of awareness, connecting a flash or a USB to one of these devices and just causing it to be contaminated or like infected with a worm or with a virus. The typical scanning tools that we have in IT, most likely they don't work perfectly with the OT environments. Yet there are like lots of efforts that are being done there actually to improve this thing and to have the right tools and systems similar to what we have in IT to do the proper scanning for OT as well. Poor access control, it is one of the key things there in OT, because as we mentioned, because the capacity of like some of these field devices is very limited, and you do not really expect to have like tools implemented or deployed into these end devices, like for example antiviruses. Most of these field devices, they will not have the capability actually to have some kind of antivirus being installed or any kind of tool that would assist you to remotely pull, for example, the configuration or to adjust it in a way from a security perspective that would assist you to make it hardened or secure. So in order to address one of the key major issues in OT, they define based on the ISA, which is international standards, the ISA 95, what is referred to as the PIRA model, which is the Purdue Enterprise Reference Architecture model. And this model basically, what it tried to do is it divided the different architectural zones within the ICS architecture into different levels. And this assisted us as architects to a certain extent to properly understand what kind of assets should we expect into each one of these levels, and to define explicitly the very specific set of controls that would fit into each of these levels. So you can imagine that levels from 0, 1 are more or less where you have the field devices, as we mentioned earlier, the sensors, the actuators, the real actual physical devices. They are in level 0 and 1. Level 2 more or less will have the monitoring machine or the local supervisory machines, and then level 3 will have the regional ones, similar to those that in level 2, but they have their regional coverage. Where level 4 is more or less your enterprise network. So this is where you have, for example, your ERP solution. The next slide actually maybe have a closer view on this model. So here you can see the different components that you should expect into each one of these levels. And my take into this this picture basically is to show the fact that the different devices that we typically see in the IT environment, they are more or less a part of our ICS architecture. So for example, here you can see that you have workstations, servers. They could be running a Windows operating system, Unix, Linux, all these types of operating systems. More or less, they are available there into levels 2 and 3. What's quite critical here to notice as well is the interaction of levels 1, 2, and 3 with level 4. Level 4 historically tend to be the source of most of the attacks that compromise the ICS system, because level 4 is where you have your business, your enterprise network, which is most likely is connected to the internet. And if we don't have proper enforcement layer between level 3, level 3 and level 4, most likely a compromise could happen between levels 4 and the lower levels. So most of the time that architects basically spend is making sure that whatever traffic is coming from level 4 to the other levels is basically very limited, very restricted, only justified, highly justified, just to make sure that the actual ICS network, which is from level 1 to level 3, is basically made in, I would say, in the needed isolation as much as possible. Okay. On the left side, you can see basically again the different levels with the different protocols that are being used there. Some of these protocols are specific and only appropriately protocols used into the ICS environment, but some others, like the TCP/IP, is basically used all across the different layers, and it's the common protocol that's used in the IT side as well. Again, so the point that I'm trying to make here is that this model, the PIRA model, basically made for this purpose, to make it easier for us to understand the different components, the different assets, and the different protocols that we are basically using into the systems. And this is just another representation. It could look maybe a bit crowded, but it is like, just to make the idea simpler. So basically, you can see in the bottom, basically the level 0, this is where you find the actual components in the manufacturing. So you can imagine that you have like bumps, the real actual like physical devices, and then as you go in the higher levels, you start to see the typical components that we see in like the workstations, the servers that are typically into the enterprise, the enterprise side of the organization. Okay. Okay, so in order to make sure that we are understanding these risks properly and we're addressing them in a very right way, we need to have a proper, well-established risk management framework. And regardless of the type of organization that you're having, more or less you will be using either like the ISO standard, NIST, or any like COBIT, any of these like available standards to assist you to establish this framework. Here I'm just showing one example that is using ISO, the very standard ISO. You can see it on the left side of the slide, where it's basically, it starts with a very typical thing of establishing the context, conducting the risk assessment, doing the treatment for the risks, and then ending up properly communicating and monitoring them. The key thing on the right side to understand is the importance of, again, identifying the assets, making sure that we know exactly what are the assets that we are trying to protect all across this different, like a huge interconnected system. What are the, understanding the associated vulnerabilities and the associated threats, and then articulating and evaluating the associated risks based on this understanding. Here again, some of the vulnerabilities or the gaps that we can see in the OT systems. Maybe I mentioned most of them, but just to go quickly through them. So, for example, when it comes to the hosts and the endpoints, typically antiviruses are not called, so you will not find an antivirus for a PLC, for example. Batches most likely are not really allowed unless they are really coming from the vendor. And they may require the vendor to really do some kind of factory testing for them before rolling them to the OT environment. No brute force prevention, no or weak credential encryption. Encryption is something more or less completely missing to a certain extent, actually, in lots of these devices. So I can tell that still some of these terminal devices are still having, the four-digit PIN to authenticate, which is something. It's not something that you expect anymore. When it comes to the networks, again, lack of encryption, as we mentioned. Some of the firmware is outdated. It's worth mentioning here that in the ICS world in general, the time of replacing the hardware basically usually is something that happens in 20 to 50 years. So it's not something that you do frequently as we do in the IT world. So the components that you put there together in the ICS system, they are put there to last for tens of years. So most of the time, you will end up having a situation where you are using outdated software, outdated systems, simply because you need to continue to support your legacy hardware and infrastructure components. As we mentioned here earlier, monitoring is a challenge, but still, at least from security perspective, some of the solutions, they are at least being promoted as being promising to fulfill some of these gaps. Okay, so this slide here showing some statistics. They are quite interesting, honestly, when it comes to the sectors that are having most of the vulnerabilities and what are those most the common vulnerabilities. So you can see here the different sectors like energy sector, water systems, transportation systems. These are the different systems, and you can see oil and gas or energy in general is basically the most sector having the vulnerabilities. It could be the reason that maybe they continue to maintain lots of the legacy systems. They don't have maybe the frequency by which they change and upgrade systems is lagging compared to maybe the other sectors. When it comes to the vulnerabilities, you can see that the list is not really surprising for us in terms of what we are used to see in the IT world, so like buffer overflow, improper authentication, cross-site scripting, cross-site request, forgery, all these kind of different vulnerabilities like man in the middle, encryption issues. They are common in the IT world, but they are also common into the OT world as well. And eventually they will lead to some kind of denial of service, loss of review, all these kind of different like consequences of having these vulnerabilities within the environment. So in order actually to make sure that we are properly protecting our environments against these vulnerabilities, I cannot be just but a consultant, honestly. So basically, I do tend to go with some kind of a roadmap and a step-by-step kind of a process in order to basically address these gaps and the vulnerabilities. So first, to start with, it is very important actually to highlight the fact that this is a journey, and this is a maturity journey. So this is not something that you will be able to do like maybe in 1 or 2 years. This has to be done maybe properly planned for to go for, like to be integrated within the culture of the organization to be able to properly improve. So it should start with gaining the visibility. As we mentioned earlier, visibility is something really challenging into this industry. So to start with is gaining visibility is very important, which is discovering what devices are connected to our network. And then taking this into understanding the risks, the context, like the environment that we're working in, like the laws, regulations, all these kind of things. Then go into implementing the security best practices. And then we need to make sure that this is we have constantly being measured and monitored for the proper performance. This is again more or less like putting it into the context that we need to define, deploy, sustain.
Bassil, sorry to interrupt you, but
program.
Bassil, sorry to interrupt you.
Yes.
But we can't see your screen. Have you stopped your screen share?
No, I'm still.
No, you can't.
Yeah.
No, you can't see your screen.
Oh, sorry. One second. Okay, I think you can see it now again, right?
Yeah, it's back now.
Okay, thank you. Thank you for letting me know.
Thank you.
Okay, so I was just explaining basically an end-to-end approach that would start with like, you know, a proposed approach for define, deploy, sustain for an end-to-end OT program that starts with the governance, the strategy, doing a detailed capability maturity assessment, conducting risk assessments, evaluating the technologies, and then going into the deployment. So basically, in the first stage, we'll end up having a detailed list of the controls that we need to implement. And this is in the deploy where we go into deploying the controls and the associated technologies. And for the sustainability, basically, we need to make sure that we have the proper systems and tools for like assets management, threat and intelligence, and vulnerability management. Okay. These are some of the de facto standards actually that we typically use, most of the basically organizations implement. So the ISA standard is 62443 series of standards. Basically, it's not only one document, so it's basically a series of standards covering the different aspects of security all across the ICS systems. In addition to NIST, as I mentioned earlier, they are quite really active into introducing applications into this area. Like there are multiple publications. In addition to NERC, NERC, yes, it started to a certain extent more into the utilities, the electrical facilities in the States, but it is gradually actually getting quite wide recognition across other different countries outside of the states. So the last thing actually that I wanted to share with you here is some of the key, the actual stories that happened actually in the past for compromise of ICS or OT systems. So you can, I can mention here, for example, what happened to the Stuxnet, which was a very state attack, very organized attack to the nuclear plant in Iran, which affected more than 10,000 machines. Impact was really massive, despite not at that time reported. A similar attack happened for Saudi Aramco, where 30K machines or computers were impacted. So maybe it didn't really impact the operations at that time. It was limited to the end workstations, but you can see from the other examples that it could be maybe sometimes limited, but maybe because of some of the the countries that are maintained there to mitigate to a certain extent the attack or the compromise that is happening. But it could be the case, like for example in Ukraine, where the whole power grid basically went out, and this could be opportunities for lots of follow attacks actually to happen as well. So it could be like only to start with something like that, like cutting the gas, for example, or cutting the oil, cutting the electricity, causing some explosion to happen here and there. This is the kind of consequences that one country could basically do as part of the warfare. Final takeaways actually to make sure that we are on the right track. Use of enforcement zones. This concept is basically embedded within the different layers model that we explained earlier, where we need to make sure that each and every layer has proper filters and network-like protection devices between across different layers. The use of diodes and unidirectional firewalls, especially between, as we mentioned, the enterprise network and the subsequent underlying layers of the pyramid. For sure, the application of the defense of DevOps concept, which is in a sense not relying on one type of defenses, making sure that we are using all the defenses that basically are available. Continuously leverage the awareness level of our staff, our vendors, all those who are basically within our facilities. And the last point has to do with the close collaboration with third parties and vendors, because most of the compromises that happened in the past, they were more or less having a third party or insiders, basically individual involved. So working collaboratively with third parties and vendors to harden the different components of the system would considerably help as well to make sure that we are securing the environment. So sorry again for rushing, but I think I hope I managed to do it within the time. Thank you again for having me here, and I'm open to your questions.
Hi, Bassil. That was an amazing session, very deep dive into industrial control systems. Now, we do have a couple of questions. The first one is, what are your thoughts on intrusion detection systems and intrusion prevention systems for industrial control systems? Yes, yeah. So basically, as I mentioned, so some of these tools are fit and can be used for ICS systems as well. However, the key thing here is to make sure that they are properly configured. So, for example, you don't want really an auto detection tool to change the configuration just based on
sensing the content of the traffic. Because at the end of the day, the criticality of the systems controlled by these systems is really immense. So, so just to answer the question, I'd say yes, they can be used, but they need to be properly configured to best fit into the system.
Okay, the next question is, what role is AI going to play in industrial control systems? Is it going to become completely fully autonomous with absolutely zero human intervention and zero human control?
Honestly speaking, this is something that is currently still being investigated, so I haven't really seen, even in literature, really some real actual work into the consideration of AI into this extent. But I think maybe similar to other areas, it could take place, they could take use of AI as well to a certain extent. But honestly speaking, so far, nothing was so far maybe really seriously published into this extent.
Okay, my next question is, how much of an impact or how big of a role does penetration testing of industrial control systems have in the industry?
Yes, yeah. So especially for penetration testing, okay, if I understand the question correctly, so it is done for ICS systems as well, but again, it is done with a very a very cautious approach. So we don't really do it as we do it for the IT systems, mainly because these systems that we are talking about are real life systems, and you cannot risk shutting down, shutting down a system just because you are trying to prove a concept or try to show a vulnerability. Typically, it is more of like a proof of concept, the kind of work that is done. When it comes to the different layers, it has to do with the level 4 and the 3 more, but not with the lower levels.
Okay, so thank you for that answer. I think we're done with the questions as well. Thank you so much, Bassil, for giving us the time to come and share your thoughts on this interesting topic. I'm sure everyone did love your knowledge sharing session. Thank you so much. We look forward to having you for our future Reinvent events as well. And as always, please stay safe and have a good weekend ahead. Bye-bye.
Thank you. Thank you.
Bye.
Thank you. I appreciate it. Take care.
Bye.
Bye-bye.